Okay, so let's practice finding the derivative of a function, right? So not just the slope at a single point, but really truly the derivative. Okay, sorry about shifting this screen around there. Okay, so we're going to find the derivative of the function y equals, or f of x equals x squared. And we're going to compare this to when x equals 2 to the answer we got in number 7. So I just looked back and pulled this answer from number 7 just so we can refer to that later. Okay, so we're finding the derivative function. So this is denoted f prime of x. Oops, sorry, I don't know why my computer's. This is equal to the limit as delta x goes to 0 of f of x plus delta x, right? So no longer in terms of some constant, minus f of x all over delta x. Okay, so in terms of our function, delta x, I'm sorry, f of x is x squared. So f of x plus delta x, right, think about this. F of x plus delta x is going to just be x plus delta x quantity squared, right, because it's just the squaring function. Minus f of x is x squared, all over delta x. So we continue to write the limit, despite the fact that it's notationally not fun to write. And we're going to expand out x plus delta x. Remember, x plus delta x squared is x plus delta x times x plus delta x. So this is, again, not super fun to write, but we get x squared plus the outers and inners are both x delta x. So we get 2x delta x plus delta x squared, and then minus x squared. And all of this is over delta x. Notice that we have x squared and negative x squared, so I'm going to go ahead and cancel those. And so we're left with the limit as delta x goes to 0 of 2x delta x plus delta x squared. And I'm going to factor a delta x out of that numerator. Right, so I factor the delta x out of here and 1 out of here. So the delta x comes out. I'm left with 2x plus just 1 delta x over delta x. And it's at this moment right here that I want to cancel, and I can only do that because I'm taking the limit. So again, the reason I want you to keep writing the limit over and over again is because at this very moment, if you weren't writing the limit, it's not equal, it's not true, it's false, it's wrong. So may seem picky, but I do need you to do that. Now, as delta x goes to 0, we're just left with 2x. So f prime of x is 2x. Okay, we found our first derivative function. And note, this really is a function. It takes as an input an x, and it spits out the slope at that x value. So if we compare this answer to when x equals 2, so let's think about when x is 2. So I want to know, what is f prime of 2? This is asking, what is the slope of f at x equals 2? This is what we asked you to do in number 7. So f prime of 2, according to this function, should be 2 times the input, 2 times 2, or 4. And yes, indeed, this was the slope that we got when we did this back in terms of just 2. So we see that this derivative function really truly is a function, and it gives us the slope for any given input. So now if I want to quickly say, okay, great, well, what's f prime, what's f prime of 0? Well, that's just 2 times 0. The slope at 0 is 0. Let's picture our parabola and make sure all these numbers are reasonable, right? Yeah, the slope at 0 is 0. That makes sense. What if I wanted to know the slope at negative 1? That's going to be 2 times negative 1, or negative 2. Is that a reasonable thing? Yeah, sure. That looks like a slope of negative 1. We can find f prime of 5. That would be 2 times 5. That's going to be a positive slope of 10. Yeah, that makes sense. Way over here, this is going to be a pretty steep slope of 10. So this derivative function is a function. It really has an input and an output, and it takes in as an input any x value we want, and it outputs the slope at that x value.